Let's take a look at the following example. We're going to apply the induction method in this example as well. This example says, for all integers, like n larger than or equals to 3, 2n plus 1 is always less than 2 to power n. Let's apply the method of induction. So the basis step. The basis step says, hey, prove the statement for the smallest value in the domain. We show that the statement is true for n equals to 3. The smallest value, the starting value is 3. So we're going to start using 3. Okay, so it says, hey, 2 times 3 plus 1 must be less than 2 to power 3. Okay, it says, hey, 6 plus 1 must be less than 2 to power 3, which is 8. It says 7 must be less than 8, which is true all the time. Now let us go to the inductive step. Inductive step. In the inductive step, we assume that the statement is true for pk, and we're going to show that it is true for pk plus 1. We assume that pk is true. What's the meaning of that? We assume that 2k plus 1 is less than 2 to power k. Then we prove that for k plus 1 or pk plus 1. What is pk plus 1? We want to show that 2 times k plus 1 is less than 2 to power k plus 1. Put a question mark. We try to prove this guy. Very well. So let's get a little bit creative here. This is what we try to prove. You have inequality, everybody. Let's see what we can do here. Well, take a look at your pk, the initial statement. All right. Two k plus 1 is less than 2 to power k. You already know this. What I'm going to do, I'm going to add 2 to both sides. So this is my pk. This is pk, which is already true. Okay, now add 2 to both sides. Okay, I get 2k plus 1 plus 1 plus 1, which is 2, less than 2 to power k plus 2. This is what I'm trying to do. I'm just adding 2 to both sides of my pk. I'm not working with this guy. I'm trying to create this. I'm going to build this. So what do you have here? So far, you have 2k plus 1 plus 2 less than 2 to power k plus 2. Very good. Okay. It says, hey, 2k plus 3 is less than, so if you just write this guy as 2 to k plus 2, this is always less than 2 to k times 2. Why is that? This guy. So far you have 2k plus 2. Two to power k plus 2. This is always less than 2 to power k. This guy is also less than 2 to power k. 2 is always less than 2 to power k. If k is larger than 1. So far we have 2k plus 3 less than, if you just factor out 2 to power k, or just add these two together, you get 2 to power k times 2, or 2k plus 3 is less than 2 power k plus 1, which is what we try to prove. So we just proved pk plus 1. What is the conclusion? The conclusion is, by the method of induction, we proved that 2n plus 1 is always less than 2 to power n for any n larger than equals to 3.